Hi everybody, and once again welcome to Pankaj's Echelon Tutorials. And in this today's session, we are going to continue with our chemistry subject for IGCSE. And this is, I think, the fourth video, okay, on the stoichiometry that we were doing already. So we are into IGCSE 10th grade, and we are into the topic called stoichiometry in chemistry. Stoichiometry, and already I have covered some 3 videos on this. This is the fourth one, and here in this today's video I'm going to start with the mole concept as applicable to chemical equations. Now this is slightly a step higher than what you studied so far. So far what you did was you tried to convert a number of moles into the grams, or number of or from the grams of a chemical you try to convert it into moles. Then you try to relate the number of moles with the volume of a gas, and you try to connect the number of moles, the concentration, and the volume of a liquid. So all these things, you have studied individually using some 3 main formulas. And now we are going to come to a stage where we have come to a stage where we are going to apply all these rules, all these laws, to these chemical equations. And just for your, just to freshen up, I'm going to rewrite those 4 formulas once again for you. The first one is pertaining to N is equal to mass in grams upon either AR or MR, depending upon it is a atom or a molecule. Okay, this is the first formula which relates number of moles to the mass in gram. Then the next formula was relating to the gases, where the number of moles is equal to the volume of gas in decimeter cube or in liters, okay, divided by 24, right? And there was one more formula which was N is equal to concentration of a solution times the what was it? Concentration of the solution times the volume in decimeter cube or in liters. Okay. So these were the 3 formulas that we dealt with. And of course, we know that Avogadro's number 6.02 into 10 raised to 23. This is the number of particles present in 1 mole of a substance. One more thing we should recollect and we should understand is 1 mole of any substance, okay, contains 1 mole of any substance contains, say, if it is an element, it will be AR expressed in grams, okay, or 1 mole of any molecule, will be MR expressed in grams, okay. So this is also another way of understanding the meaning of these are also known as molar mass. These are nothing but molar mass, or this is molar mass. This is something called atomic mass. Okay. So these are the things that we are going to use now in our chemical equations. Okay. So these 4 formulas, you should always have back of your mind. And let us get started with this mole concept and chemical equations. So let us go to the very first example, that is this one. Now this example says that 2 magnesium plus 1 molecule of oxygen gives you 2 molecules of magnesium oxide. Okay, and it is a balanced equation. Now here it is very important that these equations that you are dealing with in mole concepts has to be balanced. If they are not balanced equation, you have to first balance the equation and then you have to proceed with other things. Okay, so this route right now we can say it is already a balanced equation. So 2 moles of magnesium plus 1 mole of oxygen gives you 2 moles of magnesium oxide. Now this can be called as mole also, and this can be called as volume also. So 2 volume of magnesium is to 1 volume of oxygen is to 2 volume of MgO. So the ratio here is 2 is to 1 is to 2, right? Fine. So in this column, below the magnesium column, I'm going to write 2 moles, and in this oxygen column, I'm going to write 1 mole, and in the column of magnesium oxide, I'm going to write again 2 moles. Okay, that is done. Fine. Now this particular example में the question okay, now magnesium, actually this question is fine. So 2 moles of magnesium. Okay, now what is 1 mole of magnesium? Now this you will have to use. 1 mole is equal to AR in grams. Okay, so 1 mole of magnesium means how much? It will be 24 grams. Right, AR of magnesium is 24, expressed in grams will be 24 grams. So this is the molar mass of magnesium. So 1 mole ka mass will be 24 grams. So 2 moles ka mass has to be 48 grams. So in the same column, I have written this 2 moles in terms of grams. So it has to be 48 grams. Even otherwise, you can use this formula. M is equal to N into AR. And N in this case is 2 moles. And AR for magnesium is 24. So it will be 24 into 2, 48. So yeah, this will be 48 gram. Okay. So that is magnesium. 2 moles is equivalent to 48 grams of magnesium. Now, same way you can do for this oxygen. Now, 1 mole of oxygen is equal to 32 grams. Now, mass in grams is equal to N into AR. Now, oxygen being a molecule, okay, you are going to write not AR, but you will write MR. Okay, so N into MR. So N is 1 mole into MR of oxygen will be 32. Okay, so that will be 32 into 1, 32 grams. So you get this 32 gram in this column. And in the same way, if you go for MgO, okay, 2 moles of MgO will be bought. So again, you will put this same formula, M is equal to N into AR. Now here, instead of AR, there should be MR. Okay, so this is, I'm being very precise about all this thing. So N into MR. So N will be 2 because 2 moles of magnesium oxide. Magnesium oxide being a molecule, you will take MR of this MgO. So MgO means atomic mass of Mg is 24 and oxygen ka atomic mass is 16. So 24 plus 16 works out to 40 and that happens to be the MR of this MgO, and that multiplied by 2 will give you 80 grams. So in this MgO column, I have put 80 grams. In short, what I want to say is 2 moles of magnesium is equivalent to 48 grams, 1 mole of oxygen is equivalent to 32 grams, and 2 moles of magnesium oxide is equivalent to 80 grams. I have written over here. Okay, fine. Now, law of conservation of mass says that the total mass of the reactants and the products in a chemical reaction is always unchanged. What I mean to say is the total of the reactant ka mass should be always equal to the mass of the product, right? So here if you see 48 plus 32 is the mass of the reactants. If you add up that, you get 80, right? And the mass of the product is also 80. So you can see that the reactant and the product, the mass is remaining unchanged. This is known as the law of conservation of mass. In any chemical reaction, the total mass of the reactants is always equal to the total mass of the products. So that has been proved over here. So that was example number 1 in which I showed you how to write an equation from the chemical equation, how you can write the number of moles ka ratio, how you can write the molar mass ka ratio. Okay. Now coming to the next one, example 2. Here he is talking about how much lime, that is calcium oxide, CaO, can be manufactured from 10 ton of limestone. Now limestone is CaCO3, calcium carbonate. You know, you get lime, that is CaO, from limestone, that is CaCO3, and this is done by heating this limestone at very high temperature, and it is processed in huge factories. Okay, and somehow you get this lime, that is calcium oxide, from this calcium carbonate. So the chemical reaction is like this: CaCO3 solid will give you CaO. This is a thermal decomposition, you can say, because there's no other reactant. So this is thermal decomposition. You will have to heat it, okay, at a very high temperature. So you will get calcium oxide, which is in solid state, and you will get carbon dioxide, which is in the gaseous state. Now we will have to check whether the equation is balanced or not. And if you see this equation, it is balanced. Okay, so 1 mole of CaCO3, 1 mole of calcium oxide, and 1 mole of carbon dioxide. That's the moles of the respective reactants and the product, right? Now, in terms of gram, let me write calcium carbonate in terms of gram. How I'll write 1 mole of calcium carbonate will be how much? So I'll go for calcium, that is 40. Okay, it's written over here. MR of calcium is 40. Then carbon ka it is 12, and oxygen, because there are 3 oxygen, so 16 threes are 48. So 40 plus 12 plus 48 works out to 100. So 100 gram becomes the molar mass of calcium carbonate. So calcium carbonate ka molar mass I have written here 100 grams in the same column of calcium carbonate. Okay, below that 1 mole. So 1 mole of calcium carbonate is equivalent to 100 gram of calcium carbonate. That's the meaning of it. Same way, coming to CaO. Now 1 mole of CaO is equivalent to Ca is 40, right? And where I've written CaO, yeah, it's over here. Ca is 40 and oxygen is just one atom, so 16. 40 plus 16 is 56. So 56 grams is the molar mass of CaO. So 1 mole of calcium oxide is equivalent to 56 grams. That is the meaning of it. And last, coming to CO2, 1 mole of CO2, it will be 44 grams. 12 for carbon, and oxygen 2 means 16 twos are 32. 32 plus 12 works out to 44. So 44 gram is the molar mass of carbon dioxide. Okay. So once you have written this equation in a balanced form, writing all the moles below it, writing all the molar mass below it, then we can proceed. Now the question is, how much lime or CaO is produced from the 10 tons of limestone? Okay. So here you have only one reactant, that is calcium carbonate, that is limestone, and 10 tons may say how much calcium oxide you will get. That's the question. So it's very straightforward. The relation between calcium carbonate and calcium oxide is 1:1, isn't it? 1:1, right? So what we will do is 100 gram of calcium carbonate, from the left hand side you can see here on the equation ka left hand side, 100 gram of calcium carbonate gives you 56 grams of calcium oxide, right? That is what this equation is telling us. So your 10 tons, now 10 ton happens to be how many grams? 10 tons will be equal to 10 into 1000 kg. That multiplied by again 1000 will give you grams. Okay, so it will be 10 is to 7 grams, right? 10 ton is equivalent to 10 is to 7 grams. So instead of 10 ton, I am writing 10 is to 7 grams, because this is also in grams, 100 gram. So 10 is to 7 gram of calcium carbonate will give you how many grams of calcium oxide? That is the question. Now, if you do the simple cross multiplication, you will get it 56 times 10 is to 7 divided by 100 grams. This much calcium oxide you will get in grams. If you work out this, it will be 56 into 10 is to 5 grams. And 56 into 10 is to 5 can be written as 5.6 into 10 is to 6 grams. And this 10 is to 6 happens to be 10 is to 6 is nothing but 1 ton. Okay, so 10 is to 6 you can replace by ton, so it will become 5.6 tons. Okay, so your 10 ton of calcium carbonate will give you 5.6 tons of calcium oxide. Okay, 10 ton of calcium carbonate will give you 5.6 tons of calcium oxide, that is lime. So that's the final answer. 10 tons of calcium carbonate will give you 5.6 tons of calcium oxide. This is how you have to deal with this chemical equation problems. Okay, we are using the mole concept in the chemical equations, right? That was example number 2. Let us move on to the next example. That is example number 3. Here he says that hydrogen gas is used as a fuel. Hydrogen burns with oxygen to give you water vapor. And the question asked is, find oxygen used A, and B, water formed when 960 decimeter cube of hydrogen gas is burned in oxygen. Now, this is a question which is relating to the use of hydrogen as a fuel. Now, when you use hydrogen as a fuel, the basic principle is hydrogen combines with oxygen, or hydrogen burns in excess of oxygen to give you water. Okay. Now, this is a very a very very innovative way of using fuel. This is a new type of a fuel, hydrogen fuel. It's very very efficient, and it's only the only problem with this fuel is this hydrogen. To handle it is a bit difficult. Otherwise, it's very efficient as a fuel. Okay, hydrogen is very efficient as a fuel. So this is the chemical reaction that takes place when hydrogen is used as a fuel. So 2s2 plus O2 will give you 2s2O. This is a balanced chemical equation. So in the hydrogen column, I'm going to write 2 moles. In the oxygen column, I'm going to write 1 mole. And in the water vapor column, I'm going to write again 2 moles because of these numbers 2, 1 and 2 in front of the molecules and the uh, in front of the molecules, right? So 2, 1 is to 2. Now these are volumes. So 2 volume is to 1 volume is to 2 volume. Or you can write 2 mole is to 1 mole is to 2 mole, right? So next what I'm going to do is I'm going to write in terms of decimeter cube. Okay, because all these three are gases, and you know that N is equal to L in liters or decimeter cube divided by 24. So moles we know this is 2 moles of hydrogen. So 2 moles of hydrogen multiplied by this 24 will give me the volume of this hydrogen in decimeter cube, and that works out to 48 decimeter cube, isn't it? And that is why instead of this 2 mole, now I have written 48 decimeter cube. Along the same lines, 1 mole of oxygen can be written as 24 decimeter cube, and 2 moles of water vapor can be written as 48 decimeter cube, right? Now, let us try to connect these two, that is hydrogen, the reactant, and the water vapor, the product. Okay. Now, what is the question? They have asked you find the oxygen used. First is find the oxygen used, and second is what is the water vapor form from 960 decimeter cube of hydrogen gas. So we now have a relation that 48 decimeter cube of hydrogen will give us 48 decimeter cube of water vapor. It's 1:1 ratio, right? So 48 decimeter cube of hydrogen is equivalent to 48 decimeter cube of water vapor, right? But in our case, in our question, they have given us 960 decimeter cube of hydrogen. So we'll write 960 decimeter cube of hydrogen will give us how much water vapor. Okay. So the answer will be 960 into 48 upon 48. That works out to 960 only. So the answer will be 960 decimeter cube of water. So for this part of the question, that is B, how much water vapor will be formed? The answer is 960 decimeter cube of water vapor will be formed. Now coming to question number A, that is how much oxygen is used. So we'll go for these two things, okay, hydrogen and oxygen. Now 48 decimeter cube of hydrogen reacts with 24 decimeter cube of oxygen. This is what the reaction is telling us, right? Because it's a balanced chemical reaction. We can always say that 48 decimeter cube of hydrogen reacts with 24 decimeter cube of oxygen. Now, instead of 48, now I want 960. So 960 decimeter cube of hydrogen will react with how much oxygen? So now if you want to work out this, you will write 960 into 24 divided by 48. Okay, you will do cross multiplication. 960 into 24 divided by 48. So here it is written 960 into 24 upon 48. 24, 48 will cut. You will get a 2 over here. And 960 divided by 2 works out to 480 decimeter cube. So this is your answer. 480 decimeter cube of oxygen is used up when you are using 960 decimeter cube of hydrogen. Okay. So this is the way you have to deal with this type of questions where they have asked you to find out certain things and they have provided you with a chemical equation. So that was the answer. So I've written your answer for A is 480 decimeter cube of oxygen and 960 decimeter cube of water vapor is formed. Right. So that's with this example number 3. Now let us move on to next example, that is example number 4. It says that calculate the volume of 1 mole per decimeter cube solution. Now this is 1 mole per decimeter cube solution of sulfuric acid. Now by this what you mean is they have given you sulfuric acid whose concentration is this. Okay, mole per decimeter cube is the unit for concentration. So C value is given. C for H2SO4, the concentration value for H2SO4 is given as 1 mole per decimeter cube. Mole per decimeter cube is the unit of concentration. So the question is, calculate the volume of this much mole, 1 mole per decimeter cube of sulfuric acid required to react completely with 6 gram of magnesium. So you are given 6 gram of magnesium and you are given this sulfuric acid whose concentration is 1 mole per decimeter cube, and these two are reacting with each other completely, and the question asked is what is the volume of this H2SO4 used up. Okay, so again I'm going to write the reaction as Mg magnesium plus H2SO4 sulfuric acid giving you MgSO4 plus S2. So this is a balanced equation. Okay, this is a very much balanced equation. Now what I'll do is this 1 before Mg I'm going to write as 1 mole. This 1 before S2SO4 I'm going to write as 1 mole of sulfuric acid. This 1 before MgSO4 indicates 1 mole of magnesium sulfate, and this 1 before S2 indicates 1 mole of hydrogen. So all the four things, two reactants and the two products, are in equal ratios, 1:1:1, that way. Okay. Now below the mole, I'm going to write now. Let us see what I can do. So this is the chemical equation which is saying that 1 mole of magnesium reacts with 1 mole of sulfuric acid, giving you 1 mole of magnesium sulfate and 1 mole of hydrogen. This is what the chemical equation is saying. Okay. Now, here the question is 6 gram of magnesium is given to you. Okay. So, first what I will do is this 6 gram of magnesium, I am going to convert it into moles. Okay. So, how I am going to do that? So you can see this statement over here. 6 gram of magnesium will be how much moles? So if I want to do this, what I'll do is I'll use this formula. N is equal to mass in gram divided by 24. Now can I do this 24? Yes. 24 gram. In fact, this is gram and this is 6 gram. Okay. So this is that formula. N is equal to the general formula I'm writing. N is equal to, one second, N is equal to mass in grams upon AR in grams. Okay, this formula I am using here. Fine. So using this formula, I am getting 6 gram upon 24, that is 1 by 4. So that works out to 0.25 moles. Okay, so 6 gram is equivalent to 0.25 mole. So here I am going to write in the column of magnesium. In the column of magnesium, I am going to write 0.25 moles. Now this is this particular line. Okay, I'll mark that in red. Okay, now let me put it in red. Okay, so sorry, these things are not working properly for me. Okay, sometimes it's horrible. Okay, let's see. Ah, it's not getting erased. Anyways, let it be like that. Okay, that's gone. Okay. So now what I'll do is 6 gram of magnesium I have converted into moles. So in the magnesium column, I'm going to write 0.25 moles. Okay. Now this is the experimental value. This is something you can say theoretical. This yellow one is theoretical, and that is what the chemical equation is saying. That is what theory says. This is theoretical, and this red one is something which is experimental value. Okay, red is experimental, right? So experiment says that 6 gram of magnesium has been taken. So 6 gram magnesium will be 0.25 mole. Now the question is 0.25 moles of magnesium if you take that, then the sulfuric acid should be how much? Now obviously when 1 mole, when the theory says 1 mole of magnesium should be equivalent to 1 mole of sulfuric acid, or it should react with 1 mole of sulfuric acid, that means 0.25 mole of magnesium has to react with 0.25 mole of this sulfuric acid as well. Okay, so this also I'm going to write in red. So 0.25 mole, right? Because this is 1:1. Okay, fine. So we have come to the conclusion that 0.25 mole of magnesium will react with 0.25 mole of sulfuric acid. Okay. Now the thing is 0.25 mole of sulfuric acid is required to react with 6 gram of magnesium. That has been done. Now they have asked you what is the volume of this much concentration of sulfuric acid. So using this formula, N is equal to V into concentration. N is equal to V into concentration. This formula we are going to use for sulfuric acid now. Okay, S2SO4. Right. So for sulfuric acid, we are going to use this formula. N is equal to V into C. So for sulfuric acid, we will take how much mole? 0.25. Okay, equal to V in volume. So that is what we want to find out. So that I am keeping as it is. V in decimeter cube multiplied by the concentration of sulfuric acid, which is given as 1 mole per decimeter cube. So if you work out this, you will get V. So V will be equal to 0.25 mole divided by 1 mole per decimeter cube. That is the concentration. This will work out to 0.25 only. The numerical value will be 0.25. And you can see a mole and mole will get cancelled and you will get 0.25 decimeter cube. So this is the answer for the volume of the sulfuric acid that is needed of this particular concentration. Okay, so our question is complete. So answer you can write as 0.25 decimeter cube is the volume of 1 mole per decimeter cube of sulfuric acid. This is the concentration of the sulfuric acid required to react with 6 gram of magnesium. Is that clear? So this is how you have to deal with these questions. So in this today's session, I have already discussed some 4 questions examples with you. In the next video, I'll be proceeding with some more examples, and slowly, steadily, I'll be taking you in this entire stoichiometry concept, and we'll be going to more difficult problems. And stepwise, we are going to complete the entire stoichiometry. Okay, so that's all for today's session, and next time I'll see you with the same topic, but there will be a few more examples on this particular topic. And if you happen to like my video, please subscribe my channel and that will motivate me to make more and more videos like this. Okay, so that's all for today. Goodbye, take care all of you.